Hello. So I'm going to discuss about the assignment 2 here. So let's quickly move on to the scope of the project. I have taken the objective of my project is to create a AML model to extract information from the medical record and also summarize that. So we are directly going to go into the opportunity evaluation. So currently the information from the medical records are manually extracted and summarized, and this involves large volume of data. The PDF often runs into several hundreds of pages, and extracting information about from them is tedious, laborious, and also marked by errors. And it takes multiple people to even work on a single PDF document. So the business impacts here. So this project is very critical because this will reduce the manual work, improve the performance, improve the accuracy, also increase the number of pages that are being completed by the team and also by the company, and in turn will also lead to increase in revenue. Availability of data. We have large volume of data, often running to hundreds of thousands of pages, and most of them being unstructured, which is a perfect case for implementation of ML model. Coming to the CRISP DM, business understanding. So we've been asked to identify the problem statement. The problem statement here is that medical record collection and processing and summarizing is often a manual work. It takes lengthy and complex and working on unstructured data often leads to inefficiencies, increasing errors, manual errors, multiple people involved in handling a document, and there is a delay in actually patient care. So we want to avoid all these things by implementing our ML model. So the outcome that we are going to measure here are reducing the processing time from the manual work to the automation work. We want to at least go for a 50% reduction in time taken by the manual work to the automation work. And we also want to track the data extraction errors. We also want to reduce the number of data extraction errors to less than 20%. And last thing is that we also want to improve the processing time, and quickly summarize all the records, and also give it to the provider so that the end patient's care is given at a quicker pace. We want to improve at least 30% increase in the decision-making time for the patients. Coming to the validation methods, so here we'll be focusing on the user identification, which is meeting with the stakeholders, which includes doctor, nurses, administrative officials. Medical coders will also be part of the key users who will be working with us in the model, and also we'll be testing that. And we'll be interviewing them, and we'll be coming with the workflow challenges in the current process. Also asking them questions like what are features that they need in the new summarization tool. Also plan for a wider survey to identify the features and functionalities that they will be expecting in the tool. So we'll take those inputs and make it in the tool. Next comes the prototype development. So we'll be working on the prototype and also showcasing the core functionalities, which is nothing but data extraction, summarization, user interface elements, and we should be able to demonstrate those capabilities of the tool. Next comes the usability testing. So here in this case, we should be asking the users to perform specific tasks pertaining to the prototype, such as extracting information from the medical record in summary, and gain feedbacks and then further improvise the tool. So this entire process is iterative, and we also focus on the feedback and improve the model as we go along till the final stage. So we'll be having doing Scrum ceremonies and multiple discussion, and this entire process we want to make it very iterative. Pilot. In this phase we'll be implementing a pilot model in the staging phase where the customers or the end users will be able to try their hands on the tool, and appropriate feedback will be collected from them, which will be used to further improve the existing model and the application. In the final phase, we will be actually doing the full-fledged evaluation where the model will be moved to the production, will be deployed to the production, and will be available for the users to test. Next comes the ML system design. So here we have been asked to define what are the key values, key things that we need to consider for ML system level architecture decisions. So first thing is the user interface. So user interface should be very intuitive. You should be able to get input from the doctors, nurses, and other professionals we'll be using the application to design the UI, and we'll also be focusing on the data extraction part. We need to, since we are going to have a extract the information from the PDF, we should implement tools like AWS Testack or Textract or Testack to import the PDF as images, then do a pre-processing, and then get the information from that pre-processing step. So all these things should be considered. Then we can also use open source models and also use rule-based approach to summarize the information from the available from the PDFs. Next, coming to the infrastructure side, so we should be having we should at least have a cloud-based infrastructure, preferably AWS or Azure, and other things that needs to be considered are containerization, API development, and compliance and security stuff. So whether Docker is needed, that should be defined, that should be make it clear. And we should also create RESTful APIs to facilitate the communication between the front-end application and the ML model. And security also should be a paramount point. We should consider HIPAA regulations and implement robust data protection and access controls. Coming to the last section, potential risk in the project. So there is latency risk. The model is very intensive. It may lead to a lot of delays in processing, and this also needs a high-end GPU to process all the information. And there is a data drift. If the model is trained on the data specific to EHR EMR, the data from other systems may not be confirmed on the same pattern or structure. So there is always a risk of data and concept drift. Often there is a change in medical guidelines and practices. So this also affects the features used for the model. There is also model bias and fairness. So if the model is trained, if the trained data is not representative of the diverse patient population, the model may perform poorly. And there is also maintenance challenges. So difficulty in collecting and maintaining the new data is also a problem. So we should also consider all these aspects while defining the model. Thank you.